Today's video is a practical beginner's guide to building desktop apps with Electron. By the end of this video, you will have built a desktop app that's installable on Mac OS, Windows, and Linux using nothing but HTML, CSS, and JavaScript. You'll learn how to combine APIs from the web, Node.js, and Electron to build a desktop screen capture. Today's video is a practical beginner available on Mac OS, Windows, and Linux using nothing but HTML, CSS, and JavaScript. You'll learn how to combine APIs from the web, Node.js, and Electron to build a desktop screen capture. It creates its own native menus, captures a video stream available on Mac OS, Windows, and Linux using nothing but HTML, CSS, and JavaScript. You'll learn how to combine APIs from the web, Node.js, and Electron to build a desktop screen capture. It creates its own native menus, captures a video stream from your system, and can write the raw video file on OS, Windows, and Linux using nothing but HTML, CSS, and JavaScript. You'll learn how to combine APIs from the web, Node.js, and Electron to build a desktop screen capture. It creates its own native menus, captures a video stream from your system, and can write the raw video file to your file system. Now, if you have no idea how Electron works, make sure to check out my 100 seconds of code video on that topic. If you're new here, like and subscribe, and grab the full source code for this project on Fireship.io. Now, before we jump into the code and turn you into an Electron developer, there's one thing you should know. A lot of people like to talk shit about Electron. And to be honest, a lot of the criticism is valid. Electron apps bundle Chromium and Node.js out of the gate, and that tends to lead to a very large app size even for a simple app. On top of that, running Chromium can be resource intensive, so your app will probably use more CPU and RAM than a comparable app in Objective-C or C#. But here's the thing, these drawbacks don't matter very much for most developers when it comes to the big picture.
Because it's fun to do bad things.
If you're a web or Node.js developer, Electron offers an amazing developer experience, and it makes desktop apps a practical business decision for companies that would otherwise not consider them. Even big companies with tons of talent and cash still choose Electron because it makes more business sense. At the end of the day, the only thing that matters is that you build an awesome user experience, which you can absolutely do with Electron. And your users don't know or care what technology you use to build the app. I think Winston Churchill said it best. Electron is the worst desktop architecture, except for all the others we've tried. Now that we have that out of the way, let's take a closer look at the desktop app we're building today. It's a simple screen recorder. It takes one of the windows that you have opened on your desktop and turns it into a video stream, and then we preview that video stream in our Electron app. When we click the record button, it will turn the stream into an actual raw video file. When you click stop, it will open another native menu, this time asking where you want to save the file output. And lastly, it writes the raw file to your system. So this will be a really fun project, because you'll need to use Node.js for certain things, web technologies for other things, and Electron APIs as well. This tutorial is designed for you to follow along, but we'll be moving at a very quick pace, so feel free to pause or slow down the playback speed. To get started, we'll first want to generate some initial boilerplate code. To do that, I'll be using an awesome tool called Electron Forge, along with its option for plain vanilla JavaScript. But if you have a preferred framework, there's all kinds of starter projects out there that you can use. And the code in this project should be relatively easy to port over to one of those. Step 1 is to open up the command line and run npx create electron app with the name of your app. Go ahead and open that up, and you'll see Electron Forge has given us a little starter project. go ahead and open up the command line and run npx create a little starter project. That's nice and all, but towards the end of the video, we'll look at how Electron Forge can help us build the actual distributables that people can install on their system. Now if we open the source directory, you can see we have an index.html and CSS. The HTML is the entry point to our front-end UI, or the render process. Then we have index.js, which is the entry point to our main process. At this point, let's go ahead and fire up the app to make sure it's working. Run npm start from the command line, and it should launch the application on your system. Now, one thing to keep in mind is that it doesn't do hot reloading like you might be used to if you work with a web framework. If you make some changes and want to see them reflected in the app, come down here to the command line, type in rs in the same terminal, and your app will restart. Let's open up this index. .js file to take a closer look at how Electron works. Every Electron app has exactly one main process, which is created by this index.js file. Up here at the top, you can see we're importing two things from Electron, app and browser window. App is used to control the lifecycle of the app, and it uses an event-based API. Let's take a look at some examples. The main event we want to listen to is ready, so we say app on ready, run this function. This event will fire once when the app is actually ready, and you can run whatever initialization logic you want here. Now, Electron Forge already set this up for us, but feel free to implement your own logic here. If we look below that, you can see we're handling a couple of other events as well, like window all closed. Because Macs have different operating system behaviors than Windows, you can run platform-specific code by checking the process platform value. This is a special value provided by Electron, and if it's a Mac it'll be Darwin or Win32 for Windows. So our app has one main process, but it can have multiple render processes going at the same time. A render process is an instance of Chromium, so you can think of each render process as being a tab or window in the browser. We create one by instantiating a browser window, and there's a bunch of different options we can pass here, but I'm going to set the node integration to true. That allows us to access Node.js globals directly in our front-end code. So that gives us an empty browser window. Now we use load file to load our index.html into it. If we look at the HTML, you can see it's nothing but a hello world. In fact, we don't even have any JavaScript running on our front end yet. Let's change that by creating a file called render.js, and then we'll add a script tag pointing to that file here in our HTML. And make sure to use the defer attribute so the script loads after the HTML. While we're in here, I'm going to go ahead and add Bulma CSS to the head of the document as well. That'll make our UI look a little more polished. Then down here in the body, we'll add a video element as well. While we're in here, I'm going to go ahead and add Bulma CSS to the head of the document as well. That'll make our UI While we're in here, I'm going to go ahead and add Bulma CSS to the head of the document as well. That'll make our UI look a little more polished. Then down here in the body, to the head of the goes after the HTML. While we're in here, I'm going to go ahead and add Bulma CSS to the head of the document as well. That'll make our UI look a little more polished. Then down here in the bottom, body, we'll add a video element to preview the actual output that's being recorded. Down below that, we'll add 3 buttons. The first button will start recording, the second button will stop recording, and the third one allows us to choose the actual video source from the system. Now let's jump into our render.js file. If you're a web developer, you can think of this as your front-end code, and it has access to everything that you would expect in the browser. Let's start by simply making a reference to the HTML elements in the DOM. We can use document query selector to grab the video element, and then we can grab our 3 buttons by using document get element by ID. Our first challenge is getting access to all of the available screens on the user's system to record. Luckily, Electron has a 3 button buttons by using document get element by ID. Our first challenge is getting access to all of the available screens on the user's system to record. Luckily, Electron has a desktop capture module that we can use right here in our render process. Let's go ahead and import the module using require. Electron actually makes the require function available in the browser. Now that we have that imported, we'll go ahead and set up a custom async function called getVideoSources, and we'll assign this function as the event handler when our video select button is clicked. In the function body, we can get access to all of the windows or screens in the system by calling desktop capture get sources. This method returns a promise, so we'll need to use the await keyword to await the actual value. The value is an array of objects, where each object is a window or screen available on the user's computer that we can record. And now that we have access to this data, we just need to implement some kind of UI element for the user to select the screen they want to record. That'd be a good use case for a native pop-up menu. Electron has a menu class, but it's actually designed to run on the main process. We can access things on the main process using a module called remote. This is one way to handle inter-process communication, or IPC. It's a very important concept, but all you need to know for now is that it allows us to build native menus directly in our front-end code here. We'll set a variable for the menu itself, and then we'll call menu build from template. This method expects an array of objects, where each object represents a different menu item. And an easy way to create that array is with JavaScript's ArrayMap method, to convert our array of input sources into an array of menu items. For each source, we'll return an object where the label is the source name, and then we'll register an event handler for click that calls another function that we have not yet implemented yet called selectSource. And lastly, we simply call popup on this menu. Now if we restart the app and click that button, you can see it gives us a list of all the windows on our system. At this point, clicking on an item doesn't do anything. That's because we need to implement our selectSource function. This will also be item doesn't do anything. You can see it gives us a list of all the windows up on this menu. Not yet implement array of menu items. For each source, we'll return an object where the label is the source name, and then we'll register an event handler for click that calls another function that we have not yet implemented yet called select source. And lastly, we simply call pop-up on this menu. Now if we restart the app and click that button, you can see it gives us a list of all the windows
虜まだらな日々に夜は長くエコーは愚か声を探すのこんな夜空にまだ一つだけ明かりがあるようだ欲しい未来はそんなになくて君がいるならそれくらいだよその次くらいに僕が入れたらそれでいいのにな会いたいの開業とでいけ痛いの痛いの飛んでいけこの感情は君がくれたのその瞬間を愛と名付けた届かぬスピが変われる僕がずっとずっと手を伸ばしてた願い事が増えるたびにぼやける朝星を集めた近づくほど辛くなるなんてどうかしてるどうかしてる君は僕に咲いた一等星眩しいからこんな心はどこかへ捨ててしまおうかなんて俺もバカな空想だ愛の体温止めて痛いと痛いをループしてこの感情は君がくれたのその瞬間を愛と名付けた惑える星は迷える僕をそっとそっと照らしてくれたこの永遠を君にあげようその瞬間は持っていられる体のスピが変わらず星が今日も明日も輝いている汚れた君は嫌いだ君を汚したあいつも嫌いだなんとなく気づいていたけど私だけじゃなかったんだよね匂わせのストーリーが更新携帯片手に欲しい見なきゃよかった悲しくなった認めたくなかった最近構ってくれないのはあいつがいたからなんだね今日も私からの LINE 汚れた君は嫌いだ君を汚したあいつも嫌いだなんとなく気づいていたけど私だけじゃなかったんだよね君にあげた好きを返してよ
Those on our system source function of our video select button will set audio to ID we pass to the function. You can await HTML real time. You should see a stream of video footage from the user's system. There's built-in recorded chunks.
いつでも戻ってきていいから前みたいに好きって言ってよ私だけに優しくしてよダメかな好き
it's our Electron app. I'm gonna use TypeScript, so I'm gonna use this template that allow me to use TypeScript in Electron. Then we're gonna install React, because when working with UI, I wanna work with React, not just pure JavaScript. And we're also gonna install Tailwind CSS for styling and all that. So let's get into it. I'm gonna copy the config for white. I'm gonna say plugin post CSS like this. So now I'm saying whenever you're compiling the render file, pay attention to any CSS file because you're gonna post CSS that. Let's run the app again. There we go. Okay, now we have Tailwind as well. Okay, now we have our app up and running. If you remember from the previous video, we had a service in Node.js. We wrote this load balancer and proxy in Node.js. If you haven't watched that video, go watch the previous video. I'm gonna link it somewhere. In that video, we coded this together, and now we're gonna import all of this to our Electron app and import them as a service, and I'm gonna use them. So at first, I'm gonna create a folder called services, and I'm gonna add a file. I'm gonna bring all of that. Okay, very good. Now we have our detect interface, which you can export. Okay, in Electron, when you have a service, Electron is like a normal web app. You have backend and you have your front end. In the back end, Electron is like a normal web app. You can have your backend and your front end and connect them together. If you want to use this detect interface, we can create a service in Electron that return all the interfaces, and in the front we can connect to that service. So here we have a file called preload. In the preload, you can add all your services, detect interface from services. Then I'm gonna import something called bridge context from Electron, and I'm gonna say get all network interfaces, and here I'm gonna say get all is a function that I'm also gonna update the window export network interface. Okay, so I'm exporting the type as well. So I'm updating the window object in browser, and I'm telling it that there is a network interface list that will return a bunch of network interfaces. Okay, so this is our service. Now in the front, we can call this and get the value from the window object, which is global. So here I can say network, I can create a state, and for now it's an empty state. I'm going to use effect. When window is available, just update that network interface for me. Oh, it's not a promise. I should change it to something like this. Okay, what I'm saying here is whenever the window object is available, there is a network interface list that you can get all interfaces. How did I do that? I use preload to attach my service to the window, which is global in the browser. So now here in the app, I'm using that service. I can now loop through them. Let me make them a little bit smaller. There we go. Very good. Now we have an Electron app that it's getting all the network interfaces. Now we want to create an UI that can show user all the interfaces. It can be an interactive UI, okay? So we should create an UI that can be interactive, and users can see different connections, choose the ratio, they can turn on and off, and they should see all the logs, things like that. So what I'm thinking about is we create something like this, small header, and we can have a switch here, can turn on.
Well, we do anticipate producing revenue at some point, so probably modify that a little bit. I'm not going to mention the inflation calc. No one cares about the inflation calc. That's So guys, this is why this tool is useful. Sometimes it just needs the DOM to better identify, especially if it's a UI bug. So you just copy and plug it in. So in this case, it appears to have found the little pesky situation. Nice. I think I discarded this one change, but it's a small change, so I'll just tell it to fix it. Awesome. Now all you need to do is make it so when I zoom, I can just still click the dates. Those shouldn't be blanked out. Excuse me. Alright, and then the other thing, which we also discarded, but should be pretty quick. And then we'll do the sampling. Alright, so you probably have this in your conversation history, but go ahead and implement the T3 chart for the ticker page. I'm going to commit that as well. Have the confidence. Succeeded. Yeah. Oh, you guys can see. So this is a premium feature. The reason why it's a premium feature is it's a really cool Excel file. Like it's as soon as you bring it into your Google Sheets, it's automatically updating the prices. It's hooked to everything, so your transaction data has all the Sharp ratios, everything that's interesting. Every day you check it, it replaces. Every day you check it, it's all the stats. I have used tons of libraries at this point, so I can say that with some degree of confidence. A little laggy on the initial load when you click around, but after it caches, it's good. All right, cool. This one's kind of untested. is just the tags.
It's our Electron app. I'm gonna use
Alright, so let's start with understanding what exactly. Do you have basic web development skills and want to turn these skills into building cross-platform desktop applications for Linux, Windows, and macOS? With Electron, it's possible, and I'm happy to offer you this complete Electron course totally for free. Electron is widely used now by big tech companies, and it's gaining very high popularity, and it's used to create very popular applications like Visual Studio Code and Slack. So it's a very valuable skill to learn and will make you stand out in the market. In this course, you will learn everything you need to start working with Electron and developing cross-platform desktop applications by practically learning all Electron concepts through working on an application, starting from creating this application from scratch until building and packaging the application and making it ready for production. I hope you're excited about completing this course, and enough with the talking, let's start. Alright, so let's start with understanding what exactly is Electron. Electron is a framework for building desktop applications using HTML, JavaScript, and CSS. It uses Chromium, which is an open source browser that's used by Google Chrome, and for the system related APIs, it uses Node.js. So to understand how Electron applications work, let's see an example. Imagine you have a website, and this website is opened in a browser. So the browser will render the front end of the website, which is a bundle of HTML, CSS, and JavaScript files. And the front end will communicate with the server using REST API. And let's consider that the back end framework used in this website is Node.js, and these are the main components of the website. Now let's see what website is Node.js, and these are the main components of the website. Now let's see what is an Electron application composed of. So since the front end of the application or the UI of the application is developed using HTML, CSS, and JavaScript, Electron uses Chromium to render this front end. But since Electron applications run on operating systems like Windows, macOS, or Linux, so it needs to do some system operations as well, like to operate or handle files or call some system APIs and so on. And this is not available from HTML and JavaScript. So like Electron applications need also a backend server, right? In this case, the backend server is actually the device on which the application is executing. And the backend framework used is Node.js. So we have two parts, the front end part, which is HTML, JavaScript, and CSS, and the backend part, which is the process that runs on the user device. In this case, the user device is the server, and This process has access to all the system APIs and it's executed using Node.js. So now you might wonder, in typical websites, the communication between the front end and the back